everybody. Hope everybody is doing well. And we're going to continue with linear functions. Okay, so lastly, we looked at what a linear function was. It's an expression in terms of one variable where the powers are 0 or 1, or a combination of those two. So you can have a constant and you can have an x term. And we also saw that when you do plot a linear function, it's a straight line. It shouldn't be a curve, right? It's a straight line, no zigzagging, right? Now we also saw the standard form for a linear equation, y is equal to mx plus c, where m is the gradient and c the y-intercept. And we went a bit into detail about what the gradient is. It's a ratio between the difference in x values and the y values, and how we can go about finding the gradient given 2 points. So I just wanted to touch on one more thing for gradients. So the idea of a positive and a negative gradient, because we were seeing that we could get both positive and we could get also negative as an answer for your gradient. And what does that mean, right? Now we always go from left to right. So in going from left to right, if the graph is going down, that's going to be a negative gradient, right? Now, if moving from left to right, the graph is going up, then we expect a positive gradient, right? So here, the gradient is going to be negative or half. Oh, no, you all need to find that out. Anyway, you'll see that later on. So that's pretty much it for gradients. So you're going to move on to the y-intercept. So what is it? Because I made you all find it for certain questions. But what is it? So the y-intercept of a graph, right, denoted by c, once we have a y is equal to mx plus c, it's the y value of the point where the graph is going to cut the y-axis. Now, if you can remember, any point along the y-axis is going to have an x-coordinate of 0. So if you're asked to state the coordinates of the y-intercept, so it's going to be the coordinates of the y-intercept. The x is always going to be 0, and whatever the y value is, it's c from your function once it's in the standard form, right? If it's not in your standard form, y is equal to mx plus c, standard form, that's c, right? So this is the coordinate, but if I just ask you for the y-intercept, I just want this c value, right? So let's look at what here is, right? So here we have the graph, right, of y is equal to 2x minus 1. It's a straight line, so it's linear. Can anyone tell me what c is equal to in this case? But first of all, is this in our standard form?
Yes, miss.
Right, good. Right, so we have y is equal to mx plus c. So what is c in this case?
-1.
Yeah, -1, right? Some people left out the sign, right? You have to include this if it's negative, but I'll show you why. So this is the graph, and the graph cuts this is the y-axis here, right? The y-axis is the vertical one, and so it's going to cut, let me put in the y for you guys, right, and the x. Right? As you can see, it cuts the vertical axis here at this point. Okay, what's the coordinate of that point?
0, 1.
0,
-1.
-1, right? It's in line with this -1 here. Right, so once it's below the x-axis, we deal with negative values. So it's -1. Right? So once it's in standard form, you can get the y-intercept right here. And what it just means is that the line of the graph intersects the vertical or the y-axis at that y value. And as always, for your y-intercepts, the x-coordinate is always going to be 0. So I have two graphs here. Right? I want you all to determine, I'm not giving you the function of what it is, the rule, but just looking at the graph, I want you to determine for me what the y-intercept is going to be. Okay, let's call the red one f of x and the green one g of x. So for the red graph, y-intercept of f of x, what is it going to be? Where does the red line cut the y-axis? So at what point? Yes, thanks, Rochelle. 1. Everybody seeing that? Yeah. So the y-intercept is 1. Okay, what about the green one? What about g of x? What will the y-intercept of g of x be? Okay. Piana. Okay, so -2, Faith -2. Does everybody see that it's -2? Right? Because g of x, it's meeting or it's cutting the y-axis at this point, at this value of y, so -2.